starting the first chapter of NCERT Exemplar, and that is real numbers. So if you need the questions later, you can find the PDF in the description section. Let's move to the first part. The first part is choose the correct answer from the given 4 options in the following questions. And the first question states, for some integer m. So let's assume that m is an integer, right? Every even integer is in the form of what? There are 4 forms given, m, 2m, m plus 1 and 2m plus 1. How do we solve it? See, we know that the even integers are what? 2, 4, 6, 8, 10 and so on, right? Generally they are represented in the form of 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, like this. So can I say that these numbers, if you focus here, you will find these numbers, the later ones, these are the integers. So after some time, there will be a point that it will be representing 2 times m also, because we said that m is an integer, right? That's why the option C would be the correct answer. 2m is the correct form for even integers. Moving further, the next question, for some integer q, every odd integer is in the form of what? Now, this time our integer is what? Q, right? If our integer is q, then we are referring to what? Odd integers. How do we represent these odd integers? See, the odd integers are generally 1, 3, 5, 7, 9. Agree? And we know that after every even integer, there is an odd integer, and before that also there is an odd integer. So we can write it as 2 times 0 plus 1. Can we say that? Yes. Then we can say it is 2 times 1 plus 1. We can represent it as 2 times 2 plus 1, and then this is 2 times 3 plus 1 and so on, right? What is our motive here? We want to showcase these numbers. See, there are the integers. So we can also write after a certain point, it is 2 times q. Why am I taking q this time? Because our integer is q, right? And then plus 1. So in this question, our option D will be the correct answer. But there is a catch. Sometimes you don't get this option. Then in that case, you should know that these numbers can also represent it in a different way. How? Can I write 3 as 2 times 2 minus 1? Isn't it 4 minus 1, 3? And then 5, this can also be written as 2 times 3 minus 1, right? That is 6 minus 1. That is why I can say that 2 times q minus 1 is also a correct answer. So you just have to be very cautious when you are selecting the option. If 2q plus 1 is there, that is also correct. If 2q minus 1 is there, that is also correct form of odd integers, right? Moving further to the next question. It is n squared minus 1 is divisible by 8 if n is what? So when you see this question, the very first thing you have to do is eliminate the options which are not valid. So first I am going to eliminate this one. Why? It is an integer and then there is the elaborative form of odd integer or even integer. So if I have elaborated option, I would not consider integer. And at the same time, the natural number would also not be taken. Okay? Now, our answer would be either odd integer or even integer. Let's solve it. Let's say that a is equal to n square minus 1 is divisible by 8. Right? So in that case, there could be two things. Either it will be an even integer or it would be an odd integer. So let's see what works well. Okay, let's have a segregation and see the question. Now, if a is an even integer, then what is the form of even integers? Think of it. Yes, it is 2q, right? So can I write it as 2q square instead of n? I'm saying that it is in the form of even integer. The n is nothing but n is an even integer. Okay, and here n would be the odd integer. Okay, now I can say that a is nothing but 4q square minus 1. Am I right? Yes. Let's say that q is nothing but 0. Then what will be the value of a? It would be minus 1. Am I right? Now if I say that q is equal to 1, what will be the value of a? It would be 1 times 4 minus 1, that would be 3. In both the cases, we can say that it is not divisible by 8. It is not divisible by 8. Now, if I consider that a is represented by n and n is an odd integer, then it should be in the form of 2q plus 1, right? Let's open this. Now 2q plus 1 whole square is there. Make sure you are implementing the identity a plus b to the whole square. That would be 2q square, that is 2q whole square plus 2 times 2q plus 1 square plus minus 1. So it is nothing but 4q square plus 4q and then plus 1 minus 1 gets cancelled. Okay. Now we are assuming that the q is 0. What will be the value of a? A would be nothing but 0, right? Then I say like q is nothing but 1. What will be the value of a? It is 1 times 4, right? And then this is 4. 4 is 8. In both the condition, you will find that 0 and 8, they are divisible by 8. So we can say that the odd integer, option number C, is the correct answer. Okay? Now moving further to the next question. This is question number 4 and it states the HCF of 65 and 117 is in the form of 65m minus 117. Now they have actually written the HCF in this form. Right? Now we need to find the value of m. So if you want to find the value of m by given expression, it is better to find out the HCF of the given numbers. Okay? So let's start with the solution. We will find the HCF of 65 and 117. I hope you remember the Euclid's division lemma. How do we write using that? By Euclid's division lemma. How do we represent it? Can we write 117 as 65 times 1 plus 52? Now if you are thinking how ma'am has written this, let's go for the rough work. I hope this would be helpful for you. Divide 65 and write it like this. 65 times 1 and that would be 52. So this is your dividend, this is your quotient, this is your divisor and here it is your remainder. Okay, so let's put it here. Now next time we will be treating this 65 as our dividend. Now 65 divided by 52 times 1 and you will be getting 13. Again you can proceed with the normal division method and can get this equation. Now we will be taking, let's say 52, and 52 can be written as 13 times 4 plus 0. If you focus here, you will find that the HCF of 65 and 117 is obtained. So our HCF is 30. But in the question, they said the HCF is 65 and minus 117. Therefore, we will write 65m minus 117 is equal to 30. When you will hold it here and transfer 117 that side, you will be getting 130 divided by 65, and the value of m would be nothing but 2. So our option B would be the correct answer. I hope you understood what we have done. The HCF of 65 and 117 is found using the Euclid's division lemma, and then we have equalized that HCF to this expression, and that's how you reach to the value of m. Okay, moving. The question states the largest number which divides 70 and 125, leaving remainders 5 and 8. Right? So we need to find a number which is dividing both of them and leaving 5 and 8 in both the cases respectively. How do we do it? First, we note down the numbers 70 and 125. And because the remainder is there in this case, we will be subtracting 5 in the first case and then 8 in the second case. You will be getting 170. Now, most of the time we get stuck here. Now, the question is whether we use HCF or we use LCM. So, let me give you the clarity on this, because they are asking for the largest number which divides these two numbers. Right? Because they are asking for the number which divides them, so we will be using the concept of HCF. In case they ask the number which is divisible by 70 and 125, we will use the concept of LCM. I hope this is clear when to use HCF and when to use LCM. So let's find out the HCF of 65 and 117. However, we have done the same thing in the question number 4. So I'll just simply move with the process using Euclid's division lemma. Division lemma. Right? How do we do it? Let's write the equation. It is 117, that is the dividend, and then 65 times 1 plus the remainder, that is 52. Then we'll be taking 65 as dividend, 52 times 1 and the remainder, that is 13. Then our dividend will be 52 and we'll be taking 13 times 4 plus 0 as our remainder. Since here we have used 13 as the last divisor, so our HCF for 65 and 117 would be nothing but 13. That is option number A. And when you will divide 13 by 70 and 125, you will be getting the remainders 5 and 8 respectively. That is how you can check your answer. Now, we are moving to the next question. It's two positive integers A and B are written in such a way that A is equal to x cube y square and B is equal to xy cube. Right? Can we write it as x times x times x times y and also x times y times y times y? Okay? But there is a catch. What we need to find? If these two are prime numbers, means there is nothing common into them. What is the HCF of A and B? So what will be the HCF of A comma B? Now remember, a very important thing, whenever you are finding the HCF of algebraic expressions, when you are finding the HCF of algebraic expression, take least common factors, or you could say powers. And when you are finding the LCM, because we will be using further in the next question, right? You have to take the maximum common power. Right? Considering this, if you are finding the HCF, what is the least power of x here? See, it is x cube, this is x. What is the least one? Yes, single power x. And for y square and y cube, y square. So xy square will be the correct answer, and that is option number B. Right? Let's move to the next question. Now the question states, if two positive integers p and q are expressed in such a way that p is ab square and q is aqb, right? Then what is the LCM of p comma q? Okay, I told you in the previous question, when you are taking the LCM, take the highest common power available. So, if you focus, you will find that in P and Q, the highest common power of A would be AQ and the highest power of B would be B square. Right? So, can you see the option? Yes, that is option number C, and this will be your correct answer. Moving further to question number 8. Now, they say the product means multiplication, of a non-zero rational and irrational number. Now, please focus here. Here they have mentioned non-zero rational number. Because we know that 0 is also a rational number, here we do not need to consider 0. Other than 0, all the rational numbers are welcomed in this question. So, we are taking any non-zero rational number. Let's say it is 2 times 3, 2 by 3, and there is an irrational number, let's say this. So, how will you write it? It's 2 root 3 by 3. So, what is the form? It is an irrational number, and that's why we will say it is always irrational. Okay, so option A would be the correct answer. For example, if there is rational number and an irrational number written as a product, then you can say sometimes rational, sometimes irrational. Because just to make it clear for you, in case it's not mentioned that it is a non-zero rational number, you would have to take 0. And when you will multiply it by root 3, it would be 0, which is nothing but a rational number. Okay, so just one word is very important, that is non-zero. Okay, there. Question number 9. Question number 9 says the least number that is divisible by all the numbers from 1 to 10. Now you have to see all the numbers from 1 to 10 and then find out the LCM of theirs. How to do this? Let's note down all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And then factorize them. 1, it is 1 times 2. 3 is nothing but 1 times 3. Then this is 2 square, means 2 times 2. This is 1 times 5. This is 2 times 3. This is 1 times 7. This is 2 times 3. Like you will be writing 2 by 2 by 2. And then this is 3 square. This would be 2 times 5. You can simply factorize them into prime numbers. Then you have to write the LCM of numbers from 1 to 10. Now, what is required? You need to find the highest power of every prime number. For 1, obviously you can consider 1, but that's not a prime number. Let's write it. Then for 2, the highest power would be 3. Right? So we'll be writing 2 cube and then 3 square. For 5, you'll see that there is 1 5 and then there is 1 power of 7. So let's multiply that. This is 1 times 8 times 9 times 5 times 7. You'll be getting 72 by 5 times 7. And then this is 360 times 7. When you will multiply it further, you'll be getting 2, 5, 2, 0. So that is your option number D, and the answer for question number 9 would be option D, 2520. Question number 10. The decimal expansion of the rational number 14,587 by 1,250. It is up to how many decimal places? How many decimal places are there? 1, 2, 3 or 4. So, to figure out this, we are going to use the conventional method We will note down our number 14,587 divided by 1250, and we will keep our numerator stable. We won't disturb the numerator. Instead, we will factorize the denominator in its prime factors. How we will do that? It is 5 times 5 times 5 times 2, and there will be one more 5. So it would be 14,587 divided by 5 to the power 4 into 2. Since we know to make a rational number terminating, we require the denominator either in the form of 5 or in the form of 2 or the both, right? So to find out the decimal places, you need to go with the third one, that is 14,587 divided by 5 to the power 4. How many powers of 2 are less? 3 powers are less. So we will multiply the numerator and denominator both by 2 to the power 3. In that way, you will be getting 14,587 multiplied by 8 divided by 5 to the power 4 into 2 to the power 4. Right? When you will multiply the numerator, it will be 11,066.96. You can multiply on your own, and in the bottom you will be getting 10 to the power 4. Simply here, by observing the denominator, since we have 4 tens, right? There are 4 powers of 10, so the answer would be 4 decimal places. But still, if you want to do this, if you want to calculate, you can make it 1166.96 divided by 1, 2, 3, 4 zeros, cut it and put the decimal here. You will get 11.6696 as your answer, and there are 4 decimal places in this decimal expansion of the rational number. I hope you understood. Now, in the next class, we will be solving exercise 1.2. Till the time, practice it. As I mentioned, the questions are there in the description.